This amazing time-lapse footage taken by Tim Orr of the Hawaiian Volcano Observatory captured the biggest collapse ever seen. The white line marks the original extent of the delta. Explosions are throwing rocks and glass fragments inland, just out of view. Within 4 hours, 40 acres of land disappear into the sea. From the air, you can see the extent of the entire collapsed area, which includes over 100 feet of older sea cliff. The collapse shattered the cliff, exposing the main lava tube and sending a spray of lava into the ocean. These coastal skylights give us a rare glimpse of a subterranean lava river on its way to the sea. A closer look reveals delicate fingers of fluorescent orange crust growing where flowing lava catches and cools enough to harden. Surprising everyone, lava erupts from a new series of fissures during the pre-dawn hours of July 21st. The new fissures stretch out for 1.5 miles east of Pu'u'o and are producing a lot of lava. We're here in time to catch some small dome fountains and spatterbursts along the fissures. The place is alive with sound, sloshing and spattering lava, hissing rain, the beating sound of gas bubbles bursting. The lava is very frothy here at the vent, full of gas. USGS scientists collect samples of the lava, looking for potential changes with all this new activity. The original perched channel has built up, creating an elongated shield structure with a chain of perched lava ponds on top. Spattering fountains hug the edge of the pond where gas is escaping from the lava. We attempt to visit this flow on the ground and find ourselves being chased from each place we set up. When we first encounter the lava, it is flowing as fast-moving shelly pahoehoe. Within an hour, and barely a few hundred feet down slope, we are seeing sticky, slabby pahoehoe and then It's neat to see this transition within such a short time and distance. Over the winter months, repeated collapses of the shield complex have drained lava stored inside the shields and sent big channelized flows careening down slope to the upper reaches of the poly. Unlike the earlier flows, this one has formed a lava tube and stands a good chance of reaching Royal Garden subdivision below. This 500-foot-high waterspout formed when the steam plume began rotating in shifting winds, and then moved off a short distance. Small funnel clouds are common at ocean entries, but I've never seen one so large or last so long. This winter, the summit of Kilauea began to awaken and emit increasing amounts of sulfur dioxide gas. With little warning, this huge plume of volcanic gas emerged from Halemaumau crater overnight. The gas is pouring from a system of superheated incandescent cracks in the rubble at the base of the crater wall. Just before 3 this morning, a large explosion created a 100-foot wide crater in Halemaumau. This explosion blasted ash and huge rocks, some weighing more than 2 tons, out of the crater onto the rim 200 feet above. The fence at the viewing area is smashed and the entire area buried in rocks and ash. The vent sits directly below the viewing area. Most of the ash is pulverized rock, similar to the explosion debris, but there's some fresh lava too. HVO geologists are being careful to avoid the plume while picking through the rubble looking for fresh pieces of lava to analyze. A few days later, ash production has dropped and the plume is white again. The eerie silence that accompanied the ash plume has now been replaced by a loud roaring from the vent that can be heard across the caldera. While the danger of large explosions has diminished, volcanic smog, or VOG as it's known here, is a major problem. The intense VOG has forced the national park to close twice and has adversely affected many residents downwind of the vents. From high above the caldera, we get a beautiful clear view of Halemaumau, its vent and plume. Light-colored ash fallout from the third explosion shows up nicely along the track of the plume as it heads over the parking lot and to the southwest. Bursts of spatter and ash tower above the trees lining the trail to the ocean viewing area. These are the biggest explosions we've seen in years. Lava has been pouring directly into the ocean through a large single tube for most of the summer, creating the perfect conditions for steam explosions. Repeated blasts toss lava back on land and build the cone higher and higher. Several days after the eruption paused in early August 2008, lava has reappeared on top of the main shield. Excess lava stored in the system during the pause is dome fountaining and rapidly filling the pond. Draining lava pours down the throat of a large tube. Closer to the ocean, the tube system can't handle the surge of lava. We just caught this huge flow that burst from the tube and is racing towards the sea cliffs. While we know this can't last more than a day or two, it's incredible to see these molten cascades tumble into the ocean. While lava is dribbled into the ocean at several other locations over the past few months, the ocean entry at Waikupanaha continued going strong. However, shortly before its 2-year anniversary, a series of long eruptive pauses collapsed the lava tube, and the entry officially died in the early days of 2010. The Halima'uma'u vent at the volcano's summit continues to grow larger as the unstable edges of the hole collapse. The crater has more than doubled in size over the past year. Standing near the edge of the vent, HVO geologists wearing gas masks and hard hats look like visitors to another planet as they measure gases and adjust the web cameras. While the new vent is only a mile from the observation deck at Jagger Museum, it seems worlds away. As dark approaches, the lava pond becomes visible through the fume. This roiling pond, hundreds of meters down, rises and falls in response to changes in the plumbing system of this massive volcano. Home to Hawaiians for over 1,000 years, the ancient forest seems so peaceful, even as it is consumed by the encroaching pahoehoe. Both lava and leaves glow in the light from the flames and the setting sun. After dark, intense orange light from lava and fires creates an eerie glow in the forest that highlights how dangerous it is to be in these woods at night. One home has been destroyed and several others are in danger as inflating flows fill the low-lying areas and edge closer. Lava has reached the ocean and is pouring through a rock arch into the sea. It doesn't take long for a bench to begin building out along the coast. Growth comes at a price, though, as much of the lava is torn and shattered to build the new beaches that allow the island to grow. A very large flow is swiftly spreading along the coast and is about to pour over the cliff in front of us. Searing heat and methane explosions surround us as the lava begins pouring over the cliff, but the view is too mesmerizing to leave. Around 5 p.m., a new fissure ripped open between Pu'u'o and Nepal crater, much to everyone's excitement. This is very similar to the eruptive event we saw in 1997. Geologist Tim Orr is lucky enough to catch the front of the fissure as it is still opening. Magma rising from below first fractures the ground, then releases copious amounts of volcanic gas and steam. As cracks continue to open and widen, lava emerges in small bursts that gain in strength and duration. At dawn, another set of fissures opened up with a massive outpouring of lava. Some of the lava was immediately swallowed into old fissures, but much of it tore through the surrounding forest, setting off large fires. Blobs of molten spatter are flung in all directions from the fissures. Spatter that lands near the vent, but not on the moving flow, begins to build ramparts along the fissure. This fissure, closest to Pu'u'o, is the most active and is building a small spatter cone. With time, lava seals the narrow parts of the crack, localizing fountains at wider areas, where larger ramparts and even small cones can build. The fissure feeding the small cone continues to spread, opening new vents over several hours. This summer, lava is slowly filling Pu'u'o crater in the form of a perched lava lake that occasionally overflows and is also being pushed upwards as the crater floor bulges. Today, the lake surface is less than 100 feet below the crater rim. A new set of fissures has ripped open on the east side of Pu'u'o, high on the cone. Lava is flowing in a large, impressive channel, feeding a'a flows downslope. Lava in the channel is traveling nearly 10 feet per second. Farther downslope, we encounter a cascade of lava dropping and splashing into a pool, occasionally flinging blobs of lava onto the walls. Rafted pieces of crust plunge into the pool, getting coated as they roll and bob downstream. In June 2014, a new fissure split the northeast flank of Pu'u'o. Lava poured into deep fissures along Kīlauea's rift zone, traveling 1 to 2 miles underground and emerging again above the town of Pahoa. By October, lava was threatening inhabited areas, a waste transfer station, and a road carrying critical electric transmission lines. As the Pahoehoe flows approached, the road was closed and anxious residents and officials waited. In the early hours of October 25, 2014, lava crossed the Pa'a Street on the outskirts of Pahoa. A power pole wrapped in heat shielding and girded by cement casing and cinder was surrounded by lava but survived the intense heat of the flow. The flows poured through fences at the top of inhabited private property on October 28th and slowly engulfed an orchard of macadamia nut trees. The lower flows stopped before they reached the village road or any homes in Pahoa. Breakouts continued upslope, widening the flow field. On November 10th, a new flow broke out above Apa'a Street and moved toward a home. One branch of the flow moved along the road and into the driveway, and another flowed right up to the edge of the garage building, but stopped just a few feet away. Unfortunately, the main flow continued down slope and reached the house, which had been emptied weeks earlier. The house burned as lava flowed under it. Within an hour, it was completely consumed. Only the metal roof remains. Lava flowed into a fish pond below the house, causing some steam-driven spattering and boiling water. Heat from the lava flow also kept igniting methane that built up underneath the pond lining. New breakouts of lava continued above Apa'a Street and soon reached the transfer station. They first flowed around the earthen wall outside the fence and began to inflate. Then lava broke out, burned its way through the fence, and flowed down the walls. When the lava reached the asphalt at the bottom, it began to burn too. Burning asphalt makes a nasty black smoke that is unhealthy to breathe. Near the end of December, the flow front stagnated near the marketplace as the lava supply dwindled. The lava flows did not advance significantly after Christmas, and by mid-March they were dead. The residents of Pahoa could finally breathe a sigh of relief after being threatened for nearly half a year. Back in the national park at Kīlauea's summit, the active lava lake in Halima'uma'u crater continues to grow. The lake is now over 550 feet across and fluctuates between 100 to 150 feet below the crater floor. Where lava drains back along the far edge of the lake, escaping gases cause splashing and spattering. Spattering forms Pele's hair that wafts in the plume and carpets the ground around Halima'uma'u. Strands of this golden glass can be found scattered throughout the park. In late April 2015, the volcano inflated rapidly, and the lava level began rising 10 to 20 feet a day. By April 27th, lava was within 10 feet of the rim. The lake is very active, and large dome fountains surge across its surface. Sporadic rockfalls crash into the lake as heating causes the walls to expand and pop. Falling rocks agitate the lava lake and cause increased spattering and faster circulation. Larger rock slides trigger dramatic explosions, causing the lake to slosh violently in response. This is the first time since 1982 that lava has been visible to visitors at the summit, and it's drawn quite a crowd. From April 29th to May 8th, lava repeatedly overflowed onto the floor of Halima'uma'u crater. The overflows show up even better after dark, spreading slowly over the crater floor. Two new breakouts burst from Pu'uo'o, one moving south and another heading north. The southern vent is at a lower elevation and is pumping out a lot of lava, so it looks like it will become the dominant vent. A month later, flows are moving rapidly down the Pali, close to the national park boundary, eating away at one of the remaining forested kipukas. The air is filled with smoke and ash from burning trees. Few things are more mesmerizing or hotter than watching the glowing core of an flow push forward. The incandescent spiny clinker tears from the core and cascades down the front where it gets run over as the flow advances. On July 26th, lava reached the ocean for the first time since 2013. Lava initially poured over the cliffs in a single narrow stream, but others soon followed. The gradual process of land building has begun again. When lava first enters the water, it tends to shatter into glassy sand that builds a rough beach. Lava flows soon bury the beach and begin to build new land. By the end of 2016, the new lava delta covered more than 20 acres, an area large enough for 80 homes. The entire delta and part of the older sea cliff collapsed violently on New Year's Eve, leaving the severed lava tube spraying like a fire hose directly into the ocean. Months later, lava continues to pour into the water, generating littoral explosions that can throw rocks and hot spatter over the top of the 60-foot-high cliffs. Sometimes it flows as a narrow stream 5 to 10 feet wide. At other times, it widens into thin sheets that tear apart as they fall. At the summit, Halemaumau lava lake continues to rise and fall with pressure changes inside the volcano. USGS geologist Matt Patrick, who tracks these changes, took this amazing footage of splashing and dome fountaining while monitoring the lava lake during 2017 and 18. Pressure built up at Kīlauea's summit during April 2018, and the summit lava lake is filled to overflowing. On April 30th, fresh magma is injected beneath Pu'o'o, but before it can reach the surface, the cone collapses. Billowing dust and ash pour from the vent. When it clears, no lava is visible in the deep gaping hole left behind. Earthquakes begin immediately and track the magma as it moves down rift towards populated areas. As voluntary evacuations begin, steaming ground cracks form in the Leilani Estates subdivision. On May 3rd, the first fissure breaks the surface. A magnitude 6.9 earthquake jolts the island as Kīlauea's south flank shifts seaward and widens the pathway for magma. More fissures quickly follow, though the initial eruptions are small and the lava doesn't travel far. The amount of lava erupted increases with the opening of Fissure 7, cutting right through this intersection and building large spatter ramparts across several roads. Downed power lines and falling trees make the area even more hazardous. Geologists are tracking and mapping the lava flows as they become larger and begin to rapidly overrun homes. As Fissure 7 wanes, a few vents produce huge exploding bubbles in the viscous lava. In 6 days, 15 fissures erupt in Leilani Estates, then stop. The earthquakes and ground cracking continue, so we know it isn't over yet. On May 12th, the eruption resumes through new fissures downrift of Leilani Estates. Although these start small and viscous, they quickly begin pouring large amounts of lava from the new vents. This new lava is hotter and more fluid. Emergency evacuations are called for nearby residents and those living downslope. Much larger fountains spray from these vents, reaching 60 feet high. At night, the fissure fountains are mesmerizing, but we keep our distance as they shift unpredictably. Falling spatter is now building up large cones and ramparts along the uphill side of the fissure. Large, fast-moving flows head down slope, plowing through homes, farms, and forest. On May 19th, the first flows reach the ocean. Fissure 17 opens and is like nothing that has ever erupted on Kīlauea before. The main part of the vent is fountaining, but the upper edge erupts periodically with tremendous explosions. The lava is highly viscous, and the fountains pulse as they burst, feeding a slow-moving, like lava flow. Here is Fissure 17 from the air, with the main vent feeding a flow and the uprift end producing steam-filled bursts but little lava. During these explosions, nearby houses are pelted with huge hot falling rocks. Some of the spatter bombs fly hundreds of feet in the air and leave scorched craters when they hit the ground. One watcher, a resident, is injured by falling rocks, but all other residents wisely evacuate. A cone is building over the main vent, which continues to produce an advancing lava flow for more than a week. The molten lava is so stiff that it is remarkably hard to sample. Activity seems to be shifting back up rift as fissures 13 and 6 reactivate and produce high fountains. Lava is ponding around these larger vents before spilling out and feeding flows to the south. The fountains really vary in height and intensity. Walls of spatter build around some of the smaller fountains. Ponded lava is piling up over the road, and overflows are a constant worry. At night, burning gases are visible through cracks in the roads near some of the lava flows. Fissure 8 has reactivated and is spewing out a large flow advancing to the northeast. The massive flow has engulfed 10 properties in 10 minutes as it moves down roads. By May 29th, the Fissure 8 fountains are hundreds of feet high and a large channel is flowing northeastward. Downwind areas have tephra, frothy pumice and cinder, falling out of the sky. Between the glow, the falling rocks, and the abandoned buildings, it's eerie working out here at night. Listen for the falling pumice clattering down all around us. You can see it silhouetted against the lava fountains. The Fissure 8 fountains are impressive, and they are starting to build a large cone. While most of the spatter falls back into the vent, near the top of the fountain, the lighter tephra is blown around in the wind. Hot whirlwinds form in the incredible heat, gas, and unstable air around the fountains. These move quickly and whip hot tephra in all directions. Houses and roads downwind of the fountains are covered in a layer of glassy tephra. The amount of sulfur gas being released is unprecedented. More than 50,000 tons a day blanket the area. By June 4th, the advancing flow from Fissure 8 has reached the beautiful Kapoho coast. Within hours, one lobe of lava is flowing into the bay, but others spread sideways through Kapoho and towards Vacation Land subdivision. All roads in and out are blocked by 20 to 40-foot walls of Everyone has evacuated safely, but the sudden destruction of this iconic Hawaiian locality shocks and saddens all who love this place. By June 6th, almost all the homes are gone, the bay is no more, and lava continues spreading through the unique tide pools and reef along the coast until they too are destroyed. Lava flows into the ocean along a wide front that continuously inflates and spreads, slowly consuming the remaining nearby homes. When the lava river pours directly into the sea and flows underwater, towering steam plumes and littoral explosions are generated. This lava river is massive, and the explosions are huge. Blobs of lava are thrown hundreds of feet into the air, and waves ripple outward from the explosions. The flows leave almost no trace of the hundreds of homes that once stood here, but nearly 900 acres of new land have been added to the island. The cone at the Fissure 8 vent continues to grow, part spatter and part cinder cone. The flow fed from the cone is massive. At its widest point, the river of lava is over 1,000 feet across. Downstream, the flow branches into multiple channels. Overflows are building the levees higher and higher, and nibbling away at nearby homes and farmland. Islands and rapids form in the swift-moving lava river. Should the levees collapse, a flood of lava would spill into the surrounding homes and farms at devastating speeds. The entire channel is watched by officials 24 hours a day for signs of changes in stability. Up close to the vent, where lava spills down from the cone, we clock its speed at 18 miles per hour. The lava slows down to just a few miles per hour farther downstream, where the ground is flatter. The channel is transporting about 100 cubic yards of molten lava every second toward the coast. The heat of the open channel creates a pyrocumulus cloud that persistently hangs over the whole area. The Fissure 8 fountains have diminished and are confined within the 80-foot-high walls of the crater. The volume of lava coming out of this vent remains unchanged and exceeds the output of any eruption on Kīlauea for at least 200 years. We are witnessing a historic event. Here a type of whirlwind, dubbed a lava whirl, flings molten lava wildly as it dances along the edge of the lava channel. Beautiful to see, but only from a safe distance. A blockage in the lava channel during early July has diverted the flow to the west side of Kapoho Cone. This new channel covered a large swath of papaya farms and has extended the reach of the lava southward down the coast, threatening areas previously deemed safe, including Pohoiki Boat Ramp and Surf Spot. By late July, the behavior of lava exiting the vent is changing. Surges of lava sometimes synchronize with collapses at the summit. At other times, the lava independently pulses in a regular rhythm. Here, the lava is rising and falling by at least 30 feet over a period of 7 to 8 minutes. When the lava is running high, the standing waves are impressive and overflows are common. It's easy to forget that this roaring river of lava is running over what used to be a neighborhood. On August 4th, the eruption drastically slows. Small pools of lava are spotted in the cone until early September, then all goes quiet. In 3 months, the lava covered close to 14 square miles of land, 30 miles of road, and destroyed more than 700 homes. 1 billion cubic yards of lava was erupted, which is about 10 years of lava at normal production rates. Still, we were fortunate that over half of this lava directly poured into the ocean, or the destruction could have been much worse. While the size and ferocity of the Leilani Estates eruptions captured most of the nation's attention, another dramatic story was playing out at Kīlauea's summit. At the same time that Pu'u'o collapsed, the Halima'uma'u lava lake begins to drop. The lava lake sits atop a shallow magma body that has been storing lava for the last 20 years. The low elevation of the new fissure vents effectively pulls the plug and begins to drain the stored magma. Within 10 days, the lava lake drops out of sight, and the national park closes to the public on May 11th due to concern about the potential for catastrophic explosions. Rockfalls and accompanying ash explosions begin to dominate summit activity. The largest ash plume goes nearly 30,000 feet into the air. The Hawaiian Volcano Observatory is forced to evacuate due to the barrage of earthquakes beginning to damage the building. As lava flows steadily out the lower East Rift Zone, the summit subsides in steps, accompanied by thousands of earthquakes. For the first few weeks, collapses are explosive, but by the end of May, the vent seals and no more explosions occur. A regular cycle lasting 25 to 35 hours is established, with a buildup of many smaller earthquakes culminating in a near-daily magnitude 5 quake, accompanied by rockfalls and loud roaring sounds. Watch the crack in the wall as a magnitude 5 earthquake hits. This crack extends directly through Jagger Museum and the Hawaiian Volcano Observatory. Dust rises and roaring begins as a new collapse occurs. The collapses stop abruptly on August 2nd, coinciding with the waning of Fissure 8. 62 large collapse events happened over 3 months, subjecting local residents to more than 60,000 earthquakes and reshaping Kilauea's caldera. Halima'uma'u crater subsided into a hole 1,500 feet deeper and nearly 2 miles across, taking a parking lot and part of the crater rim drive with it. For the first time in 35 years, there is no eruption on Kīlauea. The question we all want to know is, where and when will it erupt again? It's only a matter of time.